Alright, so to continue where we left off in the last video notes, we're going to do the graphing side. So in other words, how to tell if you have an inverse, and then how to show it graphically. So the existence of an inverse means you have to be one-to-one. So what does it mean to be one-to-one? You can do, this one's what we call using the horizontal line test. It means for every x, there's exactly one y, and for every y, there's exactly one x. So in other words, there's no repeating on either x or y. Now how that differs is from in a function, we could have multiple y's that we get from different x's. So like in the quadratic, x squared, we could plug in 1 and get 1 out for y, plug in -1 and get 1 out for y. That doesn't have an inverse though. And so for an inverse, you can run the horizontal line test, just like we do the vertical, and if it ever intersects more than once, no inverse is possible. And so what we're going to do is we're going to start by graphing our function and then run the horizontal line test. So if we start with, we're going to do number 1 and 3 just like in last night's, and then in class we'll do 2 and 4. So if we start with this one here, this is a line. So our y-intercept is -1, and we go up 2 over 1, and if you want to do a couple of them, just so you have a good idea. If you have a straight edge, you can use it. If you don't, do the best of your ability. Even if straight edge could even just be your ID card, a gas card, a debit card, a piece of paper folded. Okay, so there's our line. Now if we were to run the horizontal line test, so if we were to take a horizontal line and run it up our graph, do we ever intersect the graph more than once at any given time? No. So that means an inverse exists. This is a one-to-one function. So then how do we graph the inverse? Well, you can do it a couple ways. Well, first one, we found the inverse yesterday. But let's say we didn't have the equation, we just had the graph. An inverse is a reflection about the y equals x line. So the y equals x line is this one here in red that goes through the origin and has a slope of 1. So I'm going to draw my y equals x line, or my reflection line, in red. So this is the line that we reflect over to graph the inverse. So when we're reflecting, here we're at the point 0, -1. So its reflection would be at the point 0, 1. So find some points and reflect them over that line. No, it wouldn't. Time out. Yeah, I was off on that. Sorry. We know that this point on the line will also be on our line. Let's see. The easiest way that you can do it would be to find a point, so like this one, how it's diagonally a distance of 1. So that means a distance of 1 this way. So we're trying to find perpendicular distances. If I can find another point like that, where, let's see, this one's about half, so there's half. There's another point. And in reality, we only need 2 points to make our line. So once we find some points that we can easily find a distance of either 1, or here it was about half, or it was half the distance, we know we can go the other half to get the other point. You connect those and you have the graph. So the pink line, that's your inverse. So again, because we already found the equations, you could graph the equation itself by just plugging in x's and finding y's. If you're not given an equation, you're trying to find equal distances. So finding some nice points that you might be able to find an accurate distance from, like this one, that's pretty close. But just, it's a reflection. And these are sketches, they're not going to be exact. We're going to do the best of our ability to try to make it look like that reflection. If you know you have an inverse, you can always find the equation if you'd rather find the equation and then do it from that. It's really up to you. So let's go to the number 3. And again, we'll start with graphing our original equation, which is a cubic. And so if you don't remember how to graph a cubic, your fallback is to plug in points. So if we plug in 0 for x, we get 1 for y. If we plug in 1 for x, we get 2. If we plug in -1 for x, we get 0. And if you want, you can plug in a few more. So like if we plug in -2, so -2 to the third, that'd give us -8, so -7. 1, 2, 3, 4, 5, 6, 7. And then if we plugged in +2, we'd get 9. 1, 2, 3, 4, 5, 6, 7, and I'm off my graph. So I'm only going to graph these ones. Okay, so I can sketch my cubic, and I know that this is going to go something like that because it goes off my graph. Then I'm going to sketch or draw my reflection line so that we can tell what we're reflecting over. So again, we can kind of go by a distance. So I know I have this point here. I know this one's going to have to be the same distance on the other side. Down here, I know I have to cross. If it's crossing the line on the original, it has to cross that line again. Let's see. Here we're at about half, so another half. And I think that's probably good enough for our graph. So it has to have the same shape. So if I'm just going to kind of do this so I can kind of try to match the same shape. Connect them, and it should look like the horizontal version, because that's what a reflection about the y equals x is. It kind of takes things from a vertical and makes it look more horizontal. So again, graphically, we're just trying to find these distances that are equal from a slanted line. If we wanted to, again, we found the equation over here. So we could graph this by, again, just plugging in x's. So like if we plugged in 0, we get -1. What's the cubed root of -1? -1. So we already had that one plotted. If we plug in 1, 1 minus 1 is 0. The cubed root of 0 is 0. So this one was maybe a little bit, oh no, actually it looks like it would go about there. So we could have gotten that one there. So again, you could have plugged in values or just do this distance. Again, these are sketches, so it's going to be more about the shape and making sure the general shape is the same and that the general shape is reflected. All right, so like I said, we'll do these two in class since we haven't done those equations yet. And then if you look at the back side, this is asking to just sketch the inverse. And so this is the type I was talking about where we might not have an equation, so we need to try to sketch it using that distance idea, that a reflection, you're equidistant from that line of reflection. So let's go ahead and do the first one here. So they gave us the original already. So I'm going to draw my reflection line. Which is y equals x. So already where it crosses, I know my inverse has to cross there as well. So if I try to think of a distance, that's one away. So if I go another one away, there's another point. Let's see. That's another good one. That's about one away. So if we go about one in the other direction. So if I connect these, I have my inverse. So again, instead of being a horizontal parabola, which I'm not sure if we've learned about, but we will if we haven't already, instead of being or looking like a square root graph, it's going to start looking like a vertical square root graph. Number 6 we're going to save for in class because there's a little bit of explanation needed for that one. And then this last one, on number 7 I think. Again, start by sketching the reflection line. And we're going to reflect. So this looks like it's half of that square, so the other half would be its reflection. Here, if we were to try to draw a vertical line, or sorry, a perpendicular line, not a vertical line, it's about diagonal through these two squares, so that means this one would be about up there, and this one is about 1 square, so that would be over here. So then we just connect the dots, and again it should have the same shape, just reflected. So connect those two and connect those two, and you have your reflection. Okay, so again, we're going to look at number 6 together because that 6 kind of ties in with 8 here, where we have to actually restrict our domain. Because if we run the horizontal line test, does it pass? So right here, it does not pass the horizontal line test. It's crossing at the graph at 2 points, which cannot happen. So when you get something like number 6, and you're asked to sketch the inverse, we're going to talk about how you can potentially restrict the domain so that it does have an inverse that you can actually graph. So we'll do that one tomorrow in class together, which is also kind of number 8, along with going over the graphs for numbers 2 and 4, and we'll do those after we work through the equations in class today. So again, if you have any questions on how to sketch the inverse, and keyword sketch, so not 100% accurate, just a sketch, come with them to class. We are going to still practice the finding and verifying, but we're going to be adding in some checking by graphing as well.